Okay, hello everyone. So we have another MATHCOUNTS national team type problem. So this is interesting logic and parity problem. So we have a teacher with three numbers to three students like A, B, and C. And since do not know the others' numbers, but they do know theirs, but they got those numbers anyway. And but also they know that the sum of the numbers is 14. And with that in mind, so each individual says some comments. The first person, Anna, like says, I know that Brett and Chris have different numbers. So like I'm gonna make this kind of a bit like summary. So person A says B and C are different. Okay, Anna says that. And Brett says, and I think that all three numbers are different. So it's telling us A is different from B, that's different from C. And finally says, I know all three numbers. Okay, so C says, now I know everything. Okay, so with this in mind, we want to find the product of A, B, C, and then we know that only the sum of them is 14. So let's think about the first person, Anna. Anna says like the sum is, B and C are different. So how can she actually say that? She only knows her number, right? A. And then with that in mind, like there are a couple of things you can just list. And one is you can ask yourself, what are the ways to get 14 when you add three numbers in terms of odds and evenness? So you can say all three even or two other one even. So then you can kind of go with each cases, but I'm gonna kind of skip that process because I think we only one case anyway, and I'll just do it differently. So other than checking those two cases. So the first thing is like, since we know that the person A, Anna says B and D, C is different, so maybe we should think about that same. How can she actually be careful with, like, can she say that actually? So like, think about this, B plus C from this equation is equal to 14 minus A. If like, if Anna knows the number A, so 14 minus A is known. So with that in mind, that she's telling that like B and C are different. So only way that she can actually say that if this number 14 minus A is odd number, because if 14 minus A is even, then you can actually split between B and C are equally. So which is why there's no way for Anna to say they are different. So only way that she can say that A actually odd number. So which is our first option. Okay. So again, like think about A is 1, then that's 13. So there's no way to make them equal. So that's how she can say it. If A is 2 or 4 in even numbers, like that works. Like say 2, like that's the difference 12. So you can have 6 and 6. If this is 4, that's 5 and 5. So which is possible. And since she know that B and C are different, only way that she can say if A is odd number. So which is cool. Okay. And similar story, like now B, like person B knows her, like the Brett like knows like his number, right? And like it says A is different from B, B is different from C. Maybe you can kind of think about this separately. Like think about the situation where A is like different from C, right? So in this case, I'm gonna say if A is different from C, I'm gonna write the A plus C is equal to 14 minus B. So like with the kind of similar reasoning as I have right here. So for us, like for B actually, to say A, B, and C are different, and then the Brett knows only like his number, right? So then the only way we can actually say that like if we know this difference, that's odd as well. Because if this difference is even, then A and B, A and C could be equal, which is why Brett cannot really say that. But if we have that statement, A, B, C are different, then that means B is also odd number. So which is also cool. Again, we have two odds, that's even sum, but if you want to add C to get even again, so that means that has to be even. So we know the C is even and A and B are odd numbers. That's something. But at the same time, we kind of are not done with this yet because we have a little more deduction from person like B, because like that if all A, B are different, if B, C is different, or A, C different, whatever, we kind of got that they are evenness and oddness, but more than that, we can actually have a little more. Like, for example, for like the person B still, right? We are in that situation. So like if we can say A and B are different or A and C are different, how can we really say that? What are those numbers like in terms of oddness and evenness? So like for the person B, think about this odd number. If this number is like 1, then you could have this is odd as well, which is 2, and then this could be 12, which is possible. But the rest says they are different. So that means our B cannot be really like 1 or even 3, like 3 and 3 is 6. So you can get some even that does work. And then 5, 5, 10, that's 4. So it doesn't really work, which means like B shouldn't be 1 or 3 or 5, but it could be 7, because if this is 7, then the difference will be 7, 14 minus 7. So A plus C will be 7. So you can have some different arrangement for that, which we'll look into. But even though we don't know A and C yet, at least we know B should be at least 7, but no lower than that. So that's one thing we can say for sure. But if you kind of don't buy that, there's like maybe a little bit different approach as well. But I'll just say maybe let's think about this situation. So I'm gonna kind of find a contradiction if you kind of didn't buy why 1, 3, and 5 doesn't work. So think about the case A and B is equal. So we are assuming they're equal to each other. In that case, like C would be 14 minus A minus B. But we are saying that A and B are equal. So now we know we are talking about the Brett. So let's write those in terms of B. If you make this A is B, so that means that will be minus B minus B, which will be like 14 minus 2B. So like Brett knows that like A and B, if they are equal, which we are assuming, C will be 14 minus 2B. And we want this to be impossible. How this is going to happen? Like 14 minus 2B has to be at least 0. So with that in mind, so then B has to be at least 7. So you can easily kind of make this deduction, because if A and B are equal, then this is C, but we know that A and B are not equal. So that they have to be different. So which is why this has to be impossible. that is 0 or negative. So that's why B has to be at least 7, which is cool. Okay, now we can make a kind of last statements for the Chris. Says I know all 3 numbers right now. So let's think about that case, how that's gonna be. So I will say, let's make a table. So I'm gonna say this is C and A plus B. So the situation where C could be like only 2 or 4 or 6, because we know B is at least 7. And if that's the case, then other two add up to at most 7. So that means 6 cannot be anything larger than like 6 as even. If this is 2, that means this is 12, and this is 10, and this is 8. Just be aware that we don't have many options for B, right? So like in this case, and then we want to note that all 3 are different. So for the pairwise, like if I think about A and B as a pair, for this last table, I guess. So I do have like 1, 11, but 1, 11 doesn't really like work, right? And 3, 9. Actually, let me write this: 1, 11, and 3, 9, or 5, 7. So I like that doesn't work because we want B to be at least 7. So B has to be at least 7. That's 7. That's 9. That's 11. So that looks good, right? Which is kind of fine. And if I look at the next one, but in this case, like we have C is 2, A plus B is given as one of these numbers. But how do I say those are not correct? Like the reason why we can actually say, because we have 3 options, and then all 3 actually works with the case. But the Chris says I know the answer, which means there shouldn't be more than one option. Otherwise, you cannot really tell those. So since we have 3 different the pairs for A and B, so then this is actually not the case. Okay, so I would say this is not a unique pair for AB. And the second one, like for 10, so you could have, let's say, 1, 9, or 3, 7. And now again, these 2 pairs does work for A and B with any condition except the last one, because Chris says I know those numbers now. But with that in mind, you have like 2 options, which is why that's not unique either. And the last one has like 1, 7, which is actually the only one that works with that sum. So which is why this has to be our answer. With that, so our product has to be A is like 1, B is 7, and C is 6. So which looks like our answer is 42. So this was actually a cool problem. So I kind of like really like this problem, especially when I read it like the question first time. I kind of actually couldn't get the answer immediately, so I had to think about more just to come up with a solution. So I hope that makes sense. I'll see you next time.